In this video, I will show you how to solve polynomial inequalities such as this one. The first thing we need to do is we need to get 0 on one side. So let's go ahead and subtract this 2 from both sides. So that's going to give us x to the third power minus 2x squared minus 3x. Okay, all of this cancels out, so we're going to have greater than 0. Alright, so this inequality will have the same solutions as the previous inequality. So forget about the original inequality and just focus on this one. So now we're going to solve this inequality. Alright, the key to solving this inequality is to first solve the related equation, x to the third power minus 2x squared minus 3x equals 0. Alright, so we're going to find the zeros of this equation, and those will be our boundary points. I'm noticing that we have x's everywhere, so that is a GCF that needs to come out. So if I pull out the x, that's going to leave me with x squared minus 2x minus 3. Now this looks like something that might factor. So I'm going to go ahead and try to factor it in case it factors. Okay, so this is going to give me, alright, if I can factor this, then x squared can only be x times x. 3 can only be 3 times 1. Inner plus outer must equal the middle. Inner I have 3x, outer I have 1x. The middle is negative 2x. If I had a negative 3x and a positive 1x, that would give me negative 2x. So that will happen if I have a negative 3 here and a positive 1 here. Also, negative 3 times positive 1 is negative 3, so we have factored it correctly. Now to find the zeros, I need to set each one of these factors equal to 0. So including the x. Alright, do not ignore the x, it's part of the solution. Other than that, I need to set x minus 3 equal to 0 and x plus 1 equal to 0. So I will have x equals 3 and x equals negative 1. These are the zeros of the function. Okay, now I'm going to take these zeros and plot them on a number line over here. Okay, so let's see. I have, in order, it would be negative 1, 0, and then 3. Okay, so I have negative 1, 0, and then 3. Now these are the places where the function equals 0, as shown here. Now the solution to this inequality will be the places where the function is greater than 0, not equal to 0. So these will not be solutions because they make the function equal to 0. So I will graph them, but I will show that they are not to be included in the solution set by making them open circles. Now, these boundary points are dividing the number line up into 4 intervals. I need to take a test value in each one of these intervals. Alright, so I need a value in the first interval that is less than negative 1. So for example, negative 2. Okay, now keep in mind as I check these values, solutions are going to be values that cause the function to be greater than 0. So that's what we're looking for. Will the function be greater than 0? Because that's what it takes for negative 2 to be a solution. We'll check that out. Now, I need a value in this interval between -1 and 0. This one is a little bit trickier because 0 and -1 are consecutive integers. So if I want a test value in between, I might pick something like, for example, negative 0.5. All right, that's negative halfway to -1. And again, I want to see, will the function be greater than 0 at this value? Now, between 0 and 3, that's going to be a little bit easier. I would probably either pick 1 or 2, if just sticking to whole numbers. I'll just pick 1. So let's find the value of the function at 1 and see, is it greater than 0 or not. And finally, I need a value in the last interval that's greater than 3, so I will pick 4. And again, I want to see, is the function greater than 0 there? Now, I'm going to use my calculator to help me out and make it easier to test these values. So the way I'm going to do that is, now I'm going to stick with this version of the inequality, all right, the version where I got 0 on one side, but I'm going to put the left side of this function in my calculator, my TI-30 XS multiview. All right, hit the table feature and go ahead and start typing this in. So I have x to the third power minus 2x squared. All right, so I have x to the third power minus 2x squared, and then minus 3x. All right, I'm going to go ahead and hit enter. Now, to evaluate the function at these test values, the easiest thing to do is to do ask x. So I'm going to use this mode. Okay, the calculator will only hold 3 values at a time. Okay, so let's look at the first 3 values. In fact, I think I'll do 2 and 2. So first I'm going to do -2 and -0.5. Oh look, -2 is already there. So how about -0.5? Oh wait, you know what? Hold on. I meant to overwrite this one. So -0.5. Okay. So at -2, the value of the function is -10. Okay, so I'm getting -10. And the question is that greater than 0? Well, the answer to that is no. That is not greater than 0. That is less than 0. So that means -2 is not a solution, which means none of the values in this interval are solutions. So I'm going to leave that blank. What else was on that calculator? At -0.5, the value of the function is 0.875. Okay, 0.875. Is that greater than 0? Well, yes it is. It's a positive number. That means -0.5 is a solution, which means that all of the values in this interval are going to be solutions. So I will show that by making a segment here. All of these are solutions. Now I'm going to switch and check the value of the function at 1 and 4. Alright, so I'm going to change these, and now I want to evaluate at 1 and at 4. So I'm getting -4 and 20. Okay, is -4 greater than 0? No, it is not. That means that 1 is not a solution. None of these are solutions. Is 20 greater than 0? Yes, it is. That means 4 is a solution, which means every value in this interval is a solution. So I will show that by putting an array right here. Okay, so now I have graphed the solution set on this number line. So let's go ahead and write this in interval notation. For this set of values between -1 and 0, in interval notation I will put open parentheses -1, comma 0, close parentheses. I'm using parentheses, not square brackets, for the same reason that I used open circles. Parentheses show that -1 and 0 are not included as part of the solution. For this part over here, it goes from 3 to infinity. Now, when you have your solution in two separate intervals, you join them with a union symbol. So this is the final answer in interval notation. Alright, take a look at number 2. The first thing I want to do is get 0 on one side. So I am going to go ahead and subtract 4 from both sides. So that's going to give me x to the third power minus 4 is greater than 0. Okay, now to solve this inequality, I need to solve the related equation x to the third power minus 4 equals 0. Alright, solving this will give me the boundary points on my number line. Okay, so the easiest way to solve this equation is actually to put that 4 back on the other side of the equation. So I'm going to sort of undo what I just did in a way by adding 4 to both sides. So then I'm going to have x to the third power is equal to 4. And then to solve this for x, I need to take the cube root of both sides. Alright, if I want to uncube something, you do the cube root, like this. Alright, so this will leave me with just x. So the question is, how do I do the cube root of 4? Well, I am going to use my TI-30XS multiview. Get to a blank screen. If you want to do the cube root, then you start with the 3, the root. I'm shooting for this little feature that's above the caret here, shown in green. So I'm going to hit second caret, so that 3 becomes the cube root. So I'm doing the cube root of 4. So that turns out to be this. So this is 1.587. I'm just going to put a bunch of decimals, 3 decimal places. 1.587. So that is the 0 of this function. Alright, it's the only 0. So when I go to do my number line, okay, I'm going to have 1.587 is going to be right here. Now, should I make this an open circle or a closed circle? I'm going to leave it an open circle. We want the function to be greater than 0, not equal to 0. Alright, and this is a value where the function equals 0. So this is to not be included, so I'm going to leave it an open circle. Okay, now this one boundary point separates the number line into 2 intervals. We need a test value on each side. So I need something less than this and something greater than this. So less than this would be 0. So that's going to be a great value to use. Something bigger than this would be, for example, 2 or 3. I'm just going to pick 2 because that's just the first number you get to. And like I said, looking at the first version of the inequality that we made that had 0 on one side, this is what we're judging. So we want the function to be greater than 0. That's will be considered to be a solution. So we want to see, is this going to be greater than 0 or not? Will this be greater than 0? Okay, so once again, I'm going to use my TI-30XS multiview, and I'm going to put the left side of this function in the table feature. So x to the third power minus 4. Okay, so I'm going to hit the table button, clear this out, and I'm going to have x to the third power minus 4. Okay, leave the calculator in Ask X mode. It's a good place to be. Alright, now this time we are trying to evaluate the function at these two test values, 0 and 2. So we will put in 0 and 2. So we're getting negative 4 and positive 4. So we got negative 4 for the 0 and positive 4 at 2. The question is this greater than 0? No, this is not greater than 0. That means that 0 is not a solution, and there will be no solutions here, so leave it empty. Is 4 greater than 0? Yes, yes it is. That means 2 is a solution. That means all of the values in this interval are solutions. So I will show that by putting an array over here representing all the solutions. All that I need now is to write interval notation. Okay, so my interval notation, I'm going to put 1.587 to infinity. Okay, obviously this is an approximation, but if you use 3 decimal places, I will accept it. And again, I use parentheses for the same reason I have an open circle. Parentheses show that the border point is not part of the solution. So this is it. These the solutions will be from here to here.